morning, good afternoon, and good evening, everyone. I am Lokesh, your physics teacher, and you are watching YMS Educare. आज मैं आप लोग के लिए लेके आया हूँ लेक्चर नंबर 2 ऑफ रोटेशनल डायनामिक्स, जिसमें हम लोगों को आज डायनामिक्स ऑफ सर्कुलर मोशन स्टडी करना है. डायनामिक्स ऑफ सर्कुलर मोशन. व्हाट डज डायनामिक वर्ड मीन? डायनामिक्स का मीनिंग होता है फोर्सेस अराइजेस या फोर्सेस अराइजिंग फॉर सर्कुलर मोशन. सर्कुलर मोशन के लिए कौन कौन से फोर्सेस रिस्पॉन्सिबल है? सो इंस्टेड ऑफ राइटिंग अराइजिंग, लेट्स राइट फोर्सेस रिस्पॉन्सिबल. सो डायनामिक्स ऑफ सर्कुलर मोशन का मतलब क्या है? Which forces are responsible for circular motion? Okay, 11th स्टैंडर्ड में हम लोगों ने ऑलरेडी थोड़ा थोड़ा स्टडी करके रखा है कि सर्कुलर मोशन का रीजन क्या था. सेंट्रीपिटल फोर्स, राइट. यहाँ पे हम लोगों को थोड़ा सा सेंट्रीपिटल एंड सेंट्रीफ्यूगल फोर्स पढ़ना है फॉर बैंकिंग ऑफ रोड. बैंकिंग ऑफ रोड के लिए ये वाला टॉपिक बहुत ज्यादा इंपॉर्टेंट है, क्योंकि सेंट्रीपिटल और सेंट्रीफ्यूगल फोर्स नहीं आएगा तो फिर बैंकिंग ऑफ रोड समझने में थोड़ा सा प्रॉब्लम हो जाएगा, राइट. तो थोड़ा सा हम लोग सेंट्रीपिटल एंड सेंट्रीफ्यूगल फोर्स स्टडी करेंगे इन द आर्टिकल ऑफ डायनामिक्स ऑफ सर्कुलर मोशन, एंड उसके बाद हम लोग बैंकिंग ऑफ रोड पे मूव ऑन करेंगे, राइट. तो शुरुआत करते हैं सेंट्रीपिटल एंड सेंट्रीफ्यूगल फोर्स से. ओके, सो फर्स्ट टॉपिक इज सेंट्रिपिटल फोर्स. सेंट्रीपिटल फोर्स, इसको शॉर्ट में आप FCP भी लिख सकते हो. वेक्टर क्वांटिटी है इसलिए बार का साइन दे दिया. सेंट्रिपिटल फोर्स. अच्छा, ठीक. न्यूटन का सेकेंड लॉ क्या बोलता है? व्हाट डज न्यूटन सेकेंड लॉ से? इट सेज फोर्स इज इक्वल टू मास इनटू एक्सेलरेशन. वेरी सिंपल. फोर्स इज इक्वल टू मा, F इज इक्वल टू ma. मतलब क्या है? अगर कोई बॉडी रेस्ट पे है, देन इट विल रिमेन एट रेस्ट अनलेस वी अप्लाई फोर्स. इट मीन्स unless we apply force, body is not going to move. If the body will not move, then obviously its velocity is zero. If there is no velocity, then definitely acceleration का तो कोई मतलब ही नहीं है, right? Then अगर हम लोग फोर्स अप्लाई करते हैं किसी बॉडी पे तो उसका डिस्प्लेसमेंट होगा, और मैं बोल सकता हूँ वो बॉडी कुछ वेलोसिटी या स्पीड एक्वायर करेगा, राइट. और अगर वो बॉडी की स्पीड इंक्रीज होती है, देन वी से दैट द बॉडी इज एक्वायरिंग एक्सेलरेशन. पहले पढ़ा, एक्सेलरेशन किसकी वजह से आ रहा है? फोर्स की वजह से, राइट. एक्सेलरेशन किसकी वजह से आ रहा है? फोर्स की वजह से, करेक्ट. तो कोई भी बॉडी का अगर एक्सेलरेशन हो रहा है तो मैं बोलूंगा वो किसकी वजह से आ रहा है? फोर्स की वजह से, राइट. तो अगर मैं बोल रहा हूं आप लोगों को कि सेंट्रिपिटल फोर्स है हमारे पास, क्या है? सेंट्रिपिटल फोर्स. इसका मतलब हमारे पास एक और चीज होनी चाहिए. क्या होनी चाहिए? सेंट्रिपिटल एक्सेलरेशन. और एक्सेलरेशन कब आएगा? जब आपकी बॉडी का वेलोसिटी क्या होगा? चेंज होगा. इट शुड नॉट रिमेन कांस्टेंट. अगर आपकी बॉडी का वेलोसिटी कांस्टेंट है, सपोज एट पॉइंट ए वेलोसिटी आपकी v है, एट पॉइंट बी आपकी वेलोसिटी फिर से b है, एट पॉइंट c अगेन इट इज v. सो फ्रॉम a to c योर वेलोसिटी इज नॉट चेंजिंग. इट इज कांस्टेंट बिटवीन पॉइंट्स a, b and c. दैट इज v v v. तो वेलोसिटी चेंज ही नहीं होता, एक्सेलरेशन नहीं आएगा. पर सर्कुलर मोशन एक थोड़ा सा कॉम्प्लिकेटेड है, नहीं, थोड़ा सा इजी है. बट यहाँ पे अगर एक चीज ऑब्जर्व करेंगे हम लोग सर्कुलर मोशन में, सपोज करते हैं कि ये आपका एक पार्टिकल है विच इज परफॉर्मिंग सर्कुलर मोशन, राइट. दिस इज द पोजीशन ऑफ पार्टिकल, दैट इज पोजीशन A. ओके, योर पार्टिकल इज एट पोजीशन A. सपोज कि आपका पार्टिकल एंटी क्लॉकवाइज सेंस में सर्कुलर मोशन परफॉर्म कर रहा है, राइट. तो अगर ये पार्टिकल पॉइंट ए पे है, थोड़े टाइम के बाद मैंने बोला कि चलो अच्छा ये पॉइंट बी पे आ गया. दिस पार्टिकल इज परफॉर्मिंग सर्कुलर मोशन, बट कैन आई से द डायरेक्शन ऑफ इट्स लीनियर वेलोसिटी विल बी अलोंग इट्स टेंजेंट. मतलब क्या सर? देखो, आपके पार्टिकल को जाना ऐसे था. बहुत अच्छा कॉन्सेप्ट है, बहुत मजा आएगा पढ़ने में. आपके पार्टिकल को जाना ऐसे था, ठीक है. दिस इज लीनियर वेलोसिटी. आपके पार्टिकल को जाना ऐसे था, पर इसको किसी ने अंदर बुला लिया, दिख रहा है आपको, इस डायरेक्शन में बुला लिया किसी ने। मतलब सर फिर से बोलो, आपके पार्टिकल को जाना ऐसे था, किसी ने अंदर खींचा इसको, अंदर की तरफ खींचा इसको, ठीक है, तो अब ये ऐसे जा रहा है। ओके, अब आपके पार्टिकल को फिर से ऐसे जाना है, देखो ना ये स्ट्रेट लाइन है ना, पर ये अब ऐसे नहीं जाएगा, इसको फिर से किसी ने अंदर खींच लिया, लो भाई, अब इसको किसी ने अंदर खींचा तो ये ऐसे जाने लग गया, राइट। अब फिर से इसको स्ट्रेट जाना है, पर ये फिर से स्ट्रेट नहीं जाएगा, इसको फिर से कोई अंदर खींच लेगा, लो भाई, अब ये ऐसे जाने लग गया, सपोज करो। अब अगेन इसको स्ट्रेट लाइन में मूव करना है, ठीक है, पर फिर इसको कोई अंदर खींच लेगा, ऐसा, ठीक है। सो अगर आप सर्कुलर मोशन को बहुत क्लोजली देखेंगे ना, तो हर पॉइंट पे, मतलब एट पॉइंट ए, सपोज एट दिस पॉइंट, एट दिस पॉइंट, एट दिस पॉइंट एंड एट दिस पॉइंट, and can I say at every point the direction of velocity is changing. If velocity is changing, then definitely acceleration is going to come, right? So acceleration आने का रीजन क्या है? सर्कुलर मोशन में आपकी वेलोसिटी बदलती है। I am saying velocity is changing. What about speed? Speed may इंक्रीज और डिक्रीज, डजंट मैटर एज ऑफ फॉर नाउ, जरूरत ही नहीं है स्पीड की, इसकी स्पीड 2 मीटर पर सेकेंड हो सकती है, नॉट 2 मीटर पर सेकेंड, इट इज 2 रेडियन पर सेकेंड, क्योंकि घूम कैसे रहा है सर्कुलर मोशन में ना, सर्कुलर मोशन में घूम रहा है तो इसका ओमेगा कुछ होना चाहिए। आई एम अज्यूमिंग कि इसका ओमेगा टाइम के साथ बदल ही नहीं रहा है, दैट इज 2 रेडियन पर सेकेंड, मतलब at point A 2 radian per second, at this point, at this point, at this point, at this point, at each and every point on the circumference of a circle, पार्टिकल की स्पीड चेंज नहीं हो रही, पर एक चीज बदल रही है भाई, क्या बदल रही है? पार्टिकल का डायरेक्शन बदल रहा है, देखो यहाँ पे कुछ और है, 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 इसका मतलब क्या है? सर्कुलर मोशन इज एन एक्सेलरेटेड मोशन। क्या वर्ड बोला सर मैंने अभी? सर्कुलर motion is an accelerated motion. Accelerated motion, सर्कुलर मोशन एक एक्सेलरेटेड मोशन है, मतलब सर्कुलर मोशन में आपकी बॉडी एक्सेलरेट करती है, जिस डायरेक्शन में आपकी वेलोसिटी का, ये डायरेक्शन किसका है भाई? वेलोसिटी का है, इसी डायरेक्शन में एक्सेलरेशन होगा, पर वो एक्सेलरेशन कौन सा है? दिस इज विच वेलोसिटी? दिस इज लीनियर वेलोसिटी। विच वेलोसिटी? लीनियर वेलोसिटी, राइट। सो लीनियर वेलोसिटी के लिए आपका एक्सेलरेशन भी क्या होगा? लीनियर एक्सेलरेशन। फॉर लीनियर वेलोसिटी योर एक्सेलरेशन विल बी लीनियर, पर कैन आई से दिस लीनियर वेलोसिटी इज अलोंग द टेंजेंट? ये वेलोसिटी ऐसा मुझे लगता है कि अलोंग द टेंजेंट काम करता है, टेंजेंट पे काम करता है। देखो कहाँ काम कर रहा है? टेंजेंट पे। कहां पे काम कर रहा है भाई? टेंजेंट। इसलिए इस लीनियर वेलोसिटी का एक और नाम है टेंजेंशियल वेलोसिटी। ज्यादा फेमस कौन सा नाम है? टेंजेंशियल वेलोसिटी। एंड बिकॉज ऑफ दिस टेंजेंशियल वेलोसिटी कैन आई से आवर टेंजेंशियल एक्सेलरेशन विल अराइज, राइट? टेंजेंशियल एक्सेलरेशन विल अराइज। क्या ये टेंजेंशियल एक्सेलरेशन ही है जिसकी वजह से सर्कुलर मोशन हो रहा है? आंसर इज नो। टेंजेंशियल एक्सेलरेशन तो टेंजेंट में काम करता है ना? पर मैं देखता हूं कि मुझे जाना स्ट्रेट था, पर मैं तो मुड़ गया। मुझे जाना स्ट्रेट है फिर मुड़ गया भाई, जाना स्ट्रेट है फिर मुड़ गया। इसका मतलब समवन इज देयर एट द सेंटर। कोई है अंदर से जो इसको पुल कर रहा है। कौन पुल कर रहा है? सेंट्रिपिटल एक्सेलरेशन। कौन है? सेंट्रिपिटल। सर 2 एक्सेलरेशन? हाँ 2 एक्सेलरेशन है। एक एक्सेलरेशन है along द टेंजेंट, एक एक्सेलरेशन है along द रेडियस। देख लो भाई, along द रेडियस, इसको मैंने खींचा अंदर की तरफ, इसको मैंने खींचा अंदर की तरफ, इसको मैंने खींचा अंदर की तरफ, तो सेंट्रिपिटल एक्सेलरेशन नाम है सेंट्रिपिटल, टूवर्ड्स द सेंटर, सेंटर सीकिंग, ठीक है, ये मीनिंग है किसका, सेंट्रिपिटल एक्सेलरेशन का। सेंट्रिपिटल एक्सेलरेशन, सेंट्रिपिटल एक्सेलरेशन, सेंट्रिपिटल एक्सेलरेशन का डायरेक्शन क्या है, टुवर्ड्स द सेंटर, ACP। सेंट्रिपिटल एक्सेलरेशन का डायरेक्शन क्या है, टुवर्ड्स द सेंटर एंड अलोंग द रेडियस। इसका डायरेक्शन क्या होगा भाई, टुवर्ड्स द सेंटर एंड अलोंग द रेडियस, अलोंग द रेडियस। ये हमेशा सेंटर के टुवर्ड्स ही काम करेगा, हमेशा सेंटर के टुवर्ड्स, हमेशा सेंटर के टुवर्ड्स, हमेशा सेंटर के टुवर्ड्स एंड अलोंग द रेडियस, रेडियस पे ही काम करता है। ये छोटी सी प्रॉपर्टी, वन ऑफ द प्रॉपर्टीज हो गई किसकी, सेंट्रिपिटल एक्सेलरेशन की, ठीक है। एक्सेलरेशन ऐसे तो आएगा नहीं, एक्सेलरेशन किसकी वजह से आ रहा होगा, अभी तो बताया मैंने, फोर्स इज इक्वल टू मास इनटू एक्सेलरेशन, राइट, फोर्स इज इक्वल टू मास इनटू एक्सेलरेशन। तो ये एक्सेलरेशन किसकी वजह से आ रहा है, सेंट्रिपिटल फोर्स की वजह से। सेंट्रिपिटल एक्सेलरेशन इज arising due to centripetal force, right? Now the one thing that is going in my mind, that what should be the formula of centripetal acceleration, what should we write, what should we write, yeah, what should be the formula of centripetal acceleration? This thing we have already studied in 11th standard. अब ऐसा मत बोलना कि मैं क्या मर जाऊं, हाँ, सड्डा कुत्ता सड्डा, जोक नहीं, जोक नहीं, ओके। सो यहाँ पे सेंट्रिपिटल एक्सेलरेशन का मैं फॉर्मूला आपको एक्सप्लेन कर देता हूं कैसे आता है वो, ठीक है, फिर उसको पुट कर लेंगे सेंट्रिपिटल फोर्स के फॉर्मूले में, जिससे हम लोगों को सेंट्रिपिटल फोर्स का फॉर्मूला भी मिल जाएगा। आई होप आप लोग को सेंट्रिपिटल एक्सेलरेशन और फोर्स का काम क्या होता है वो समझ गया है। फिर से बताता हूं, ये जो पार्टिकल है जाना स्ट्रेट चाहता है, पर ये अंदर की तरफ मुड़ गया, मतलब इसने अंदर से खींचा, अंदर से कौन खींचेगा, खींचना, पुल करना, सेंट्रिपिटल फोर्स, सेंट्रिपिटल फोर्स, सेंट्रिपिटल फोर्स की वजह से कोई भी पार्टिकल, कोई भी बॉडी सर्कुलर मोशन परफॉर्म कर पाता है। सेंट्रिपिटल फोर्स की वजह से कोई भी बॉडी क्या परफॉर्म कर पाता है, कोई भी बॉडी क्या परफॉर्म कर पाता है, सर्कुलर मोशन, ठीक है। इट्स का मतलब क्या मेरे को समझ में आया, द फॉर सर्कुलर मोशन ऑफ एनी बॉडी और एनी पार्टिकल सेंट्रिपिटल फोर्स इज necessary, right? So for, can I write, should I write, okay, for circular motion of any object, which force is necessary, which force is necessary for circular motion of any object, centripetal force, centripetal force is necessary. Which force is necessary? Centripetal force is necessary. Centripetal force नहीं होगा तो क्या होगा सर, body will not perform circular motion. I'll give you some examples of centripetal force so that we can understand how centripetal force work for the circular motion. Okay? यहाँ पे सबसे पहले फोर्स के बारे में स्टडी करने से पहले फटाफट एक्सेलरेशन का फॉर्मूला देख लेते हैं, फिर उसको पुट कर लेते हैं फोर्स के फॉर्मूले में, और कुछ फॉर्मूले हम लोगों को मिल जाएंगे, राइट। लेट मी रब दिस क्विकली। ओके, अब हम लोग ध्यान से देखते हैं, बहुत मजा आएगा। देखो, नाउ आई एम टॉकिंग अबाउट सेंट्रिपिटल एक्सेलरेशन, जिसको हम लोग रिप्रेजेंट करेंगे ACP, सेंट्रिपिटल एक्सेलरेशन, राइट। इसका फॉर्मूला होता है सबसे पहले, देखो अगर मैं वेक्टर साइन में बताऊं, दिस इज -r ओमेगा स्क्वायर, ये बार का साइन दे दो, बार का साइन दे दो। 11th स्टैंडर्ड में इसका प्रूफ होता था। कैसे करते थे, देयर आर टू मेथड्स, वन इज by geometrical method, other method is by calculus method. calculus method थोड़ा easy होता है, दो बार डेरिवेटिव लेने का। किसका, डिस्प्लेसमेंट का डेरिवेटिव लिया, वेलोसिटी का डेरिवेटिव लिया, एक्सेलरेशन। क्या बोल रहे हो सर, नहीं समझा? पहला वीडियो देखो ना फिर तुम लोग फिजिक्स का, यार क्या करो तुमने, पहला वीडियो नहीं देखा तुम लोग ने? पहला वीडियो देखो, उसमें मैंने अच्छे समझाया है। डिस्प्लेसमेंट का डेरिवेटिव लेते तो क्या आता है? वेलोसिटी, एंड देन व्हेन वी टेक डेरिवेटिव ऑफ वेलोसिटी वी गेट एक्सेलरेशन. So that is how we get centripetal acceleration as minus r bar omega square. This is vector form. Why there is a negative sign in the formula? Because radius vector and acceleration both are oppositely directed. मतलब अगर acceleration इधर हो रहा है बॉडी का, रेडियस हमेशा इधर की तरफ शो होगा. अगर रेडियस ऊपर की तरफ है तो acceleration नीचे की तरफ होगा. यही मीनिंग है? हाँ यही मीनिंग है. एक्सप्लेन भी करता हूं मैं आप लोग को. अभी इसका स्केलर फॉर्म बोलूं तो इन स्केलर फॉर्म, ठीक है? स्केलर फॉर्म, स्केलर फॉर्म में कैसे लिखना है? सिंपल, a इज इक्वल टू आर ओमेगा स्क्वायर, सेंट्रीपिटल है इसलिए एसीपी लिख दिया. ऑल्सो वी कैन राइट सेंट्रीपिटल एक्सेलरेशन एज रेडियल एक्सेलरेशन. अच्छा, इसी चीज को मैं ए आर बार लिख सकता था, ए आर बार. अब ये क्या हो गया सर? आर क्या है? रेडियल एक्सेलरेशन. क्योंकि सेंट्रिपिटल एक्सेलरेशन का डायरेक्शन हमेशा आपको टुवर्ड्स द सेंटर और अलोंग द रेडियस दिखेगा. टुवर्ड्स द सेंटर समझा? अलोंग द रेडियस मतलब रेडियस पे ही काम करेगा. इट विल ऑलवेज एक्ट ऑन द रेडियस या अलोंग द रेडियस. इसे नाम दे दिया रेडियल, रेडियस से रिलेटेड ना, रेडियल एक्सेलरेशन. सो इधर यू कॉल इट रेडियल एक्सेलरेशन और यू कॉल इट centripetal acceleration, right? Okay, let's move forward now. So this is the first formula. Very simple, very authentic, आना चाहिए. बहुत simple है, ज्यादा difficult नहीं है. Now let's move on to the second equation that we are gonna write. Okay, so as I was saying, to derive the second formula, we'll say that V is equal to R omega. This formula we already know that V is equal to R omega, right? We're gonna use this formula in this equation. How? Let me write this as ACP is equal to R omega square. ACP is equal to R omega square. Can I write R omega square as R into, can I write omega square as omega into omega, right? So omega square ko we can also write omega into omega, but here we can see that R omega is already V. So instead of writing R omega, can I write V? In place of R omega, I am writing V, and omega we're gonna copy. So ACP we will get as V omega. This is our second formula. Now let's talk about third formula. How we are going to derive the third one. So to formulate the third formula, now we will write this formula again. What is this? This is ACP is equal to R omega square. Now we will multiply in this equation by R and divide by R. After multiplying R and dividing by R, can I write R and R as R square, and omega square we will copy, and in the denominator there is already one R, right? Can I write R square omega square as combined R omega the whole square divided by R. Again R omega is your V, right? So instead of writing R omega, now we'll write V, and the whole term is squared, right? So this will become V square divided by R. So again we are getting ACP as V square by R. So how many formulae are there? 3 formulae. Number 1, ACP is equal to R omega square, where R is your radius of circle. R is your radius. If this is our circle, then R should be the radius of this circle, right? And omega is angular velocity. With what angular velocity our particle is revolving in a circle, right? So this was our first formula, and to get the second formula, we wrote R omega as V. We splitted omega square as omega into omega, and in place of R omega we wrote V. So we got ACP as V omega. To get the third equation, we multiplied and divide by r in equation 1. Then I wrote r and r as r square, and r square and omega square I wrote combined as r omega the whole square, and r omega is nothing but v. So it became v square by r. It became v square by r. So there are three formulae in centripetal acceleration. Right. Now we'll talk about centripetal force. How we are going to derive the formula, or we're going to formulate the formula of centripetal force. So let me rub this. I hope you have already copied this. Okay. So let me remind. So okay, there were three formulae, right? One is ACP is equal to r omega square. Second was v omega. Third one is v square by r. These are the formulae that we need to keep in our mind, right? Based upon these formulae, numericals are to be done. Okay. So now, by Newton's second law, second law of motion. What is Newton's second law of motion? It is basically force is equal to mass into acceleration. If I consider our acceleration as centripetal, then can I say this force will also become centripetal? So this is the basic formula, okay, which we got from Newton's second law of motion. Now we have three formulae of centripetal acceleration. Now we'll put ACP as r omega square, ACP as v omega, ACP as v square by r, right? So we will get three formulae for centripetal force, right? Let's write the first equation. So FCP is equal to, we will copy this m and write r omega square as ACP. Because ACP, the first formula of ACP is r omega square. So we'll write this as r omega square. So can I write FCP as mr omega square? This is the first formula that we got from centripetal acceleration for centripetal force, right? Now for second equation, in the same equation, we will write v omega in place of ACP. So can I say our centripetal force will become, copy m as it is, and in place of ACP we'll write the second equation. We have already completed this. Now I am putting this value. This is v omega. So this is the second formula for centripetal force, right? Now the third formula is v square by r. This is the most prominent equation in all of them, because we'll use this many times in our numericals. Okay, so this is the most prominent one. Do not forget this. This is very, very important, very, very significant. Okay, so now in place of ACP is equal to v square by r. So in place of ACP we'll write v square by r. So can I say FCP will become mv square by r? Most prominent equation of all. Okay, so this is first formula of centripetal force, that is mr omega square. Second formula is mv omega, and third formula is mv square by r. Okay, all of the equations are written in scalar form. They have not been represented in vector form. How do we represent these equations in vector form? Let me show you that also. Now let's look at the directions of r and centripetal force, right? So let me make a radius vector. How do you make a radius vector? It's a line drawn from the center of a circle, right, to the position of a particle. Suppose my particle is somewhere here right now. This is position A, right? So how do we make radius vector? From the center to the position. From the center to the position, right? So this is how we make radius vector. So can I say the direction of radius vector is away from the center of circle? Direction of r bar is away from away from center of circle, away from center of circle, right? Now we will talk about centripetal force. The name itself suggests you that it's a center seeking force. That means it will always be directed towards the center of circle. That means FCP is directing towards the center. So can I say your force is directing towards the center and you are making radius vector as away from the center? They are oppositely directed. They are oppositely directed. So if I want to write equation number 1 in vector form, then it will be written as FCP bar is equal to mr omega square. mr omega square. Omega is a scalar quantity. M is a scalar quantity, but your radius vector is a vector quantity, and your force and radius vector are oppositely directed. So we write a minus sign in the equation. This is vector form. Vector form. I hope you all are understanding, you all are getting what am I trying to make you understand, right? So this was all about centripetal force. Now let me tell you how this centripetal force works. If I talk about a few examples of centripetal force, then the example number 1. Can I say Earth revolves around the sun, right? If this is the sun and this is Earth, so Earth is revolving around the sun, right? Earth is revolving around the sun. If any body is performing circular motion, which force is necessary? Which force is necessary? Centripetal force, right? But what does Newton's third law say? It says that there should always be two forces to balance each other. Forces always occur in pair. Forces always occur in pair. If Earth is revolving around the sun, then it should have centripetal force, but to balance this force there should be another force, that is gravitational force. How does gravitational force came in between? Earth has mass, sun has mass. So between two masses there will always be gravitational force, but this gravitational force is balancing with centripetal force, okay, because of which Earth is revolving around the sun. So our first example for centripetal force is what? Earth revolves around the sun. Earth revolves around the sun, and the necessary centripetal force is provided by the gravitational force of attraction between Earth and sun. Between Earth and sun. This was our first example. Now let me take another example. Example number 2. What if I have a string, and at one end of the string I have a stone. I am revolving this stone, or I can say I am whirling this, right? I am doing this way. Okay, I am making this stone move like this. What is going to happen? What is going to happen? Can I say there is a force present in the string, that is tension. That is tension. Tension is always directed away. If I am holding this string at this point, then can I say our tension is directed away? Our tension is directed away. But tension is the only force here to make this situation? Answer is no. There should always be two forces. If we are revolving this stone in a circular path, then there should be two forces, right? One force is tension, and this tension force is getting balanced with centripetal force. Okay, so if you have a stone, okay, if you have a stone and if you have a string which is tied at one end of the string, if you have a string and you have a stone, you are tying your stone at one end of the string and you are making a circle. You are revolving this, right, like this, right? So there are two forces. One force is tension force, and tension force is getting balanced with centripetal force. This was our second example. Is there any other example remaining? Yes, there is another example. Example of electrons and nucleus. Can I say electrons also revolve around the stationary nucleus? So nucleus also has charges, and electron itself is a charge. So forces present or force present between any two charge is electrostatic force. But to balance this electrostatic force, there should be another force, that is centripetal force. Okay, if electron is revolving around the stationary nucleus, then electron is having centripetal force. But this centripetal force is balanced by which force? Electrostatic force of attraction. Electrostatic force of attraction, right? So in the third example, we saw electrostatic force is getting balanced by centripetal force, or I can say centripetal force is balanced by electrostatic force. Okay, and now we have fourth example. Which is fourth example? I am telling you example of centripetal forces. Example of centripetal force. Okay, now the fourth example is, if suppose there's a car which is taking a turn. If the car is taking a turn, okay, if a car is taking a turn, then obviously centripetal force is needed. But to tackle that centripetal force, or I can say to balance the centripetal force, there should be another force to balance that centripetal force. So that force is frictional force between the tires and road. So while taking a turn, the necessary centripetal force is provided by the friction between the road surface and tire. These were the examples of centripetal force. I hope you have already understood the concept of centripetal force. Okay, and the direction of radius vector and centripetal force are opposite. The direction of R bar and FCP is opposite. Okay, now let's move on to centrifugal force. What is centrifugal force? The name itself suggests the direction of centripetal force is towards the center. Again, let me repeat myself. Centripetal force is center seeking. So centrifugal force should be away from the center of the circle, right? So let me rub this and make that diagram also. Okay, so now we are studying centrifugal force. What is centrifugal force? Let me give you a simple example. If suppose you are sitting in a bus, okay, and that bus is taking a turn towards right, what will happen? What will you experience? Can I say if the bus is taking a right turn, then definitely you are going to get an outward pull. Your bus is taking a right turn, then you will experience a force or a pull towards left, right? Why is it happening? Did somebody apply force on you? Answer is no. Then what is this happening with you? So can I say this is nothing but a force which is called as centrifugal force. Centrifugal force is also known as pseudo force. It is also known as pseudo force. It is pseudo force, FP. What is pseudo force? It is an unreal force. When would we get to know that we have to apply the formula for centrifugal force? Always remember, the formula of centripetal force we use when we see something revolving, when we see something is happening in front of us. But now for centrifugal force, you are yourself sitting on a rotating frame. So to understand better about pseudo force or centrifugal force, we should have some basic knowledge of frame of reference. Frame of reference. Okay, there are two types of frame of reference. One is inertial frame of reference. Inertial frame of reference. And second one is non-inertial frame of reference. Non-inertial frame of reference. Frame of reference. The another name for inertial frame of reference is non-accelerated frame of reference. Non-accelerated frame of reference. FOR, frame of reference. Another name for non-inertial frame of reference should be accelerated frame of reference. Accelerated frame of reference. What are you talking, sir? What is inertial frame of reference? What is non-inertial frame of reference? In non-accelerated frame of reference or inertial frame of reference, all the Newton's laws of motion are valid. All the Newton's laws of motion are valid. Okay, so in non-accelerated frame of motion, okay, non-accelerated frame of reference, all the Newton's laws of motion are valid. All the laws of motion are valid. But in this case, they are not valid. Why is it so? Why in a non-accelerated frame of reference all the laws of motion are valid, and in this frame of reference Newton's laws of motion are not valid? Simple example is, if suppose there's a car going in this direction, and there are two persons, okay, sitting in car. One is person A and this is person B. If person A look at person B, person A is looking at person B, what would this person will observe? What would this observe? This person will observe that person B is at rest with respect to the person A. Person A will say, okay, person B is at rest. Okay, so can I say person A is saying that B is in non-accelerated frame. B is not moving. Right? But if there is another person or third person, that is person C. Person C is looking at this car, and in this car there are two persons. So person C is saying that, okay, the whole car is moving. So person B is also moving. So for person C, B is moving. And for person A, B is not moving. Which one is correct? Who is right? Who is wrong? Answer is, it is all depending upon your frame of reference. In which frame you are standing. The another name for a non-accelerated frame is, okay, so non-accelerated frame, non-accelerated, it is not accelerating. It means you are in rest frame simply. So your accelerated frame should be moving frame. Moving frame. Always remember pseudo force, the formula of pseudo force. We will always apply pseudo force in moving frame. In moving frame, the frame should move. The frame should move. Okay, always remember this. So centrifugal force. What? Centrifugal force. What if we have to define what is centrifugal force? What is centrifugal force? The force. See, this is center of the circle. This is position of particle A. Okay. Centripetal force was acting towards the center and along the radius, and centrifugal force will act away from the center. This is the direction. This is radius vector r bar, and the direction of centrifugal force FCF, the direction of centrifugal force is away from the center, away from the center. The formulae of centripetal and centrifugal forces are same. The formulae for both of them are same, but the small difference in both of them is a sign difference. Can I say centrifugal force is going away from the center of circle, and this radius vector we are making away from the center of circle? It means they are in the same direction. They are in the same direction. If they are in the same direction, if vectors are in the same direction, then we add all of them, right? So if I want to write the formula of centrifugal force, FCF, then I'll write mr omega square, mr omega square. Make this as a vector, make this as a vector. Now we'll put a positive sign. Why, sir G? Because FCF and R bar both are in the same direction. If vectors are in same direction, we'll put a positive sign. If they are in opposite direction, then we'll put a negative sign, right? So this is the formula of centrifugal force in which form? Vector form. Okay, the formulae are same. Only the sign difference is there, right? Now let's take few examples of centripetal and centrifugal force. Okay, so we have already seen a few examples of centripetal force. Now let's look at few examples of centrifugal force. Centripetal force will always push you or pull you towards the center, but centrifugal force will always push you away from the center. Okay, the best example of centrifugal force is that passenger wala example. You are sitting in a bus and the bus is taking a right turn, then obviously you are going to get an experience or outward pull towards left. Okay, bus is going right, but you are experiencing a pull towards left. See, bus is taking right, circle right towards the center. You should have gone, but you're not going towards the center, you're going away from the center. This is the first example of centrifugal force. There's only one example, answer is no. What is the second example? Second example is bulging of earth and flattening of earth. What is bulging? See, we consider in most of the cases that earth is spherical, but in few cases we also say that there are few scientists who say that earth is oval in shape. Can I say this is the equator of earth, and this is equator, right? And this is axis. What if we press this? What if we are pressing earth? If we press earth, then can I say on equator it is bulging, it is coming out, right? And on axis what is happening? We are flattening. So why is this happening? Why is it coming out? It is coming out away from the center of circle, right? So this is another example of centrifugal force, right? So flattening of earth. This is equator, so this should be pole, right? I was saying axis, but this is pole, right? So let me write this as P. This is pole. So flattening at the pole and bulging at the equator is happening due to centrifugal force. Okay, this was the second example. Now the third example. Suppose we have a bucket. This black portion is a bucket. Okay, and in this bucket we have water. Okay, and now we are revolving this like this with a certain amount of speed. What will you observe? Will the water in the bucket spill out? If we obviously revolve it in a circular manner, okay, with a certain speed, answer is no. Water will not come out. What will happen? Let me tell you that. If suppose we have this bucket, okay, and we have water in it. This is the bucket. You want to revolve this bucket like this. At this point, our bucket will look like this. there is water inside. There is water inside, right? But water is not coming down. Water is not coming down. Why is it happening? See, the weight of the water is always directing in downward direction. It is always directing downward. Okay, but there is one force that is acting away from the center. This is the center, and away is this. Right? This is centrifugal force. So the weight of the water is balanced by centrifugal force, because of which your water does not spill out of the bucket. Right? This is the simple reason of water is not coming out of this bucket. Right? So this was the third example of centrifugal force. And there was another example that was given in your textbook, that is centrifuge machine. What? Centrifuge machine. What does this machine do? So if suppose we have a mixture in if suppose we have a mixture in a test tube. Suppose this is a test tube, and this test tube has some mixture. Okay, some amount of water and some amount of powder. Okay, we want to make we want to separate both of them. What will we do? We will keep this in centrifuge machine. What will happen? It will rotate like this, and your water and your powder will get separated. Okay, why is it happening? Why is it happening? Because you're revolving in this way. You're revolving your machine this way. Okay, you have put your test tube in the machine, and your machine is revolving this way. Okay, so all the solid that is there in the test tube, will what will happen? It will get stick to the surface of test tube, and only water will remain in between. Right? This was another example of centrifugal force. Okay, I hope you understood the concept of centripetal and centrifugal force in a better way. Okay, if you liked this video, then definitely share this video, like this video, okay, and subscribe to our channel. We are trying to make good content for you, and next video will come soon on banking of road. Thank you so much for watching this video. Now we'll meet in the next class. Okay, bye all, see you.